Hey, this is Don from Padlock Technologies again. Continuation of MPLS Inter AS L3VPNs. We did option A, we did option B. Don't know what option B is. There's going to be a card somewhere over here, somewhere that is going to point you to the video I did about option B. And then that video is going to point you to a video about option A. So today is going to be the third option out of the four options. A, B, C, and D. D is Inter-AS hybrid. Nobody really talks about that. That's going to be the next video. But on this video, we are going to talk about option C. So you remember this setup here that I got showing you here kind of looks similar to option B, but we are not doing that. So we still have the same 7-minute LSP, but between the ASBRs, we are not sharing or we are not activating the VPN before unicast AFI sub AFI, right? We're not activating that, right? This is just going to be normal BGP, labeled BGP. In iOS XR is called label unicast. So that's what we're doing here. And then we are sharing the internal network to each side. Now, we're not sharing every link between the respective service providers. We're only sharing the route reflector and the PE. This is why in my last video I said most service providers are not going to do option C. There has to be a very high level of trust to do option C between service provider A and service provider B. Why? Because we are sharing our internal network to the other ISP, right? So as you can see in between my route reflectors here, you see VPN before unicast. So what we're technically going to do is we're going to activate VPN before unicast between the route reflectors in each service provider network. And on the ASBRs, we're just going to redistribute those loopbacks to each other. And then we're going to do labeled unicast. So we're going to actually have a label sent via BGP. Remember, the four ways to create a label is LDP, RSVP, segment routing, and BGP. It's the four ways to create a label. So what we're going to technically do is we're still going to have that segmented LSP when it gets to the ABRs, and we're going to do something called next hop unchanged at the route reflector. Now, why are we going to do that? Well, very simple. When those routes come in from the VPN v4, when we share the table, the next hop technically to the PE is going to be the route reflector. Since the route reflector is not in the path in the data plane, right? We don't want it to go to the route reflector and then go to the next route reflector and then go to the PE on the other side. We wanted to go directly to the PE. So what we're going to do is we're going to do a special command at the route reflectors that say, hey, when I receive routes from the other route reflector, don't change the next hop. Just give me the next hop of wherever the PE is. And then from 7 to 1, they're just going to go directly to 1. And the other way around is going to go directly to 7. And they're just going to bypass the route reflector. So you have to do that, or you're going to end up having the route reflector be in the data path going to the other data center. Again, this is option C. Most service providers are not going to do this because they do not want to share their internal network. So I'm not going to bore you with the MPLS configurations. We've seen that a bunch of times. We have ISIS at the top, we have OSPF at the bottom. What we're going to really focus on here is the route reflectors, and we're going to focus on the ABR. So let's take a look at the route reflector. I'm only going to show you one because they're pretty much the same on the other side. So we look at this route reflector here, and let's just look at the BGP configurations and go through it. You know how I like to use my templates, so you're going to see some templates here. So here we go. So we have our template route reflector client. That's normal. If you don't want to worry about the BGP full mesh requirement, you're either going to do route reflection or you're going to do confederation, depending on how you like doing, getting around that full mesh requirement. Some people like confederation because you can still do your BGP best path selection stuff. And then some people like route reflection, but you also know that route reflection will introduce suboptimal routing because the best path is from the viewpoint of the route reflector, unless you're doing optimal route reflection. I have a video on that as well. If you're doing optimal route reflection, then you're going to do it from the PE's point of view. But if you have a route reflector, the best path is going to be selected based on how the route reflector sees the topology. Then we have this eBGP pair policy, which is going to have that next hop unchanged command. So that what that's going to do is when I advertise the route to the PEs in my whatever SP or whatever service provider network, I am not going to change the next hop to me as the route reflector. I'm going to give it to you as, hey, you need to go to the other PE in the other service provider network. This is why you have to redistribute those internal networks, because each PE needs to know how to get to each other, or it will not show up in the BGP table because, as we know, if I can't get to the next hop, best path selection is pretty much useless. That's the first thing that it needs to find out first before best path selection actually happens. Then we have our typical peer session, which is just going to be, remote AS and address update source. I could have put password on here to give it that, TCP 19. You need to know that as well because that may ask you that on a question. It's an MD5 hash and it's TCP 19 is the port for passwords in BGP. I'm gonna give you that free bit of game there because they may ask you about that in some test or something. And then we have the peer session for eBGP, and I want you to pay close attention to one command, which is eBGP multi-hop 255. Now, why would I do this? Well, when you do eBGP, it's saying, hey, I'm directly connected. That's the default behavior. So the TTL value is really like 1, right? Now you could do TTL security and up the TTL security. So you can say, hey, I might be 2, I might be 3 hops away. I'll accept something from like 3 hops away. But eBGP multi-hop is going to say the neighbor that I'm trying to peer to, the TTL value is whatever I say it to. So I put it on 255 to make it the longest TTL value, right? I could have technically did 1, 2, 3, 4, 5. I could have did 6, right? And this would have happened. But I just did 255 to be extremely lazy. Now, you'll use this eBGP multi-hop in other scenarios. One scenario that I can think off the top of my head is MPBGP EVPN multi-site. You're going to have to do BGP multi-hop to get to the other side across the DCI to establish that peer relationship or that L2VPN EVPN peer neighborship, right? But that's totally side question right now. Just follow me and just know that eBGP multi-hop will allow you to establish adjacencies that are more than 1 hop away. And then we're going to do the loop back as always, because that's what we're going to do. That's what we're going to do from a peering standpoint. So now, looks basically like everything else. We have our neighbor statements that are going to be inheriting their respective peer sessions, and then we're going to activate the neighbors on each side, the PE and the route reflector on the other side. All right, so when we go to validate that we're actually receiving routes here, we'll just do show BGP, VPN v4, unicast all summary. And as you can see, we got 5 routes coming from the other route reflector, and then we have routes coming from the PE on 65001. So if we do it in reverse, it's pretty much the same thing on the other side, right? Same configuration on the other side. We just changed some of the IP addresses around for router 7 and route reflector 3, which we're currently on. So that's the same thing there. Real important part here, though, is I'm going to show you 5 this time because we already did ASN or ASN 265001. So we're going to do 65002. So we're on 5 here. Now, first thing we're going to show you here is my prefix list. And I called it loopbacks. So as you can see, I am matching the route reflector and the PE in my ASN, right? My underlay is OSPF on this side. So I'm just matching the loopbacks, and my route map matches this IP prefix list, right? So from a BGP perspective, I'm going to, very simple. So what I did, we all know the peer session thing going on, right? eBGP peer session. What I did was I established the neighborship, and then I redistributed OSPF 1 using the loopback route map, right? And then this is a special command here, which is send label. Now you can do this when it comes to like seamless MPLS or unified MPLS. You'll be using that command a lot because that's going to say BGP is going to create the labels instead of LDP. So you're going to use BGP to create these labels, right? If you, I have seamless or unified MPLS, I forgot what the title is. I have a video on that as well. Just search it and you'll find it. I don't want to put too many cards in here because then it'll be card after card after card. But what this is going to basically say is, hey, we're going to use BGP to share labels. So you're still going to see that segmented LDP or LSP session like we saw in option B for this, right? But it is not going to be a situation where, as you can see, there is no VPN-v4 neighborship here, right? So we only have IPv4, right? So when you want to use BGP to send the labels, you have to use this send label command for the neighbor. And this is neighbor specific. Now, once we have that, and we do it on the other end, we redistribute back into OSPF. So if I go on this side, it's back in the OSPF. On the other side, it's ISIS, and it's in level 2. So as you can see, I'm redistributing BGP 65002 in the OSPF. That's how I got the internal network of SP1 into SP2. And then on the other side, this is pretty much same configuration, but from a redistribution standpoint, we are redistributing into ISIS as a level 2. Where's that redistribution? Yeah, so it's going to be by default level 2. I'm not doing it as a level 1 because technically all my routers are level 2 only, right? Because we don't have any kind of different areas, so we don't need to make it a level 1, level 2, or a level 1, right? Level 2, from a design standpoint, is a lot easier to make every router in ISIS level 2, and then you can change it to 1 and 2 later, than to do level 1 and then try to change it to level 2. You can mess up your whole design to do that, right? So just make it all level 2. So that's how I was able to get the internal network from each side into the underlay and then use BGP as the overlay to do VPN v4 and establish the peerings between the two RRs. And now when I look at the routes, which we're going to look at one PE, look at router 7, we'll just look at the BGP VPN v4 table, and you'll see that the next hop is router 1. So if I didn't, it's not the route reflector because of the next hop unchanged command. If I didn't know how to get to router 1, I wouldn't have it in the route table, and we wouldn't be none of this would work. So let's look at the BGP VPN v4 unicast. I forgot the V there. Unicast all. So as you can see, where's a loopback that I can technically use? Let's use. Let me see if I see 11. See, right here. That route right there says for router 4, technically this will be customer C, right? So when router 4 wants to get to, let's just look at the customer C. When router 14 wants to get to router 11's loopback, it's going to go to 10.255.255.1, which is this PE here. And you see from the AS path is 65001 and then a question mark. The only time you get a question mark is when you're redistributing the route. If it was normal BGP, you will not see a question mark. Case in point, we have BGP for customer A, and we have 13 and 16. And if we look in customer A's routing table and we look for 13, right here, still says the next hop is 10.255.255.1, but you see the complete AS path and you see an I there. Now you could do some trickery by using the route map and set the origin as IGP, and then you'll see the I there. But as soon as you see the question mark, just know it was redistributed into BGP from a non-BGP protocol. So if we want to go BRF, I'm gonna say cuss C, and then 10.255.255. What's in cuss C? 11/32. To give us some more detail. All right, so what we see here is here's coming from here. Now this is C, so this is the route distinguisher right here, dot 3. And then what do we have here? We got some X community values. The one that this is router C, this is all EIGRP metrics right here. So you see all this stuff right here, all EIGRP metrics. Now it's in a different format, but these are all from EIGRP because customer C is running EIGRP. And then the route target value is that there. Now I could have made it like 650.0.12.3, but I just was lazy on this one. But this is what you would see from EIGRP. These are all the default metrics, right, that come from that route. So if we did customer B, we'll see what it looks like in OSPF. You redistribute an OSPF route. So we're going to do 12, router 12, and this is going to be cus B. And as you can see, same thing. Here is the route distinguisher. Here's the route. The route distinguisher makes the route unique. So this is why you can have overlapping subnets in different VRF tables, because technically the RD is going to make it a unique route in PGP. Then you have the X community values, which is your route target value, which is RT. It'll tell you right in your face. RT 65001.2 is the RT. And then from here, you have your OSPF metrics, right? This is your OSPF metrics here, right? Router ID, the whole nine. This domain ID right here is how we can make a route appear as an inter-area route or an external route. So case in point, if the domain is different, when you do router OSPF and a number, that number is technically the domain ID, right? But you don't see it behind the scenes. So that number will actually correlate with the number that you put for the OSPF ID, right? Or the ASN. Now you can change that in OSPF by doing I think it's domain ID and then X0000. It's like this long number. Let me see if I can do this here, just so you guys can see it. I'm not going to save it, but I want you to see this router OSPF. I believe this was 2 VRF cus B, and then domain ID, and then you got to do the domain ID here. All right, so we can do type and then 0005. So it'll be 0005. And then this extra long value. So if I did 0000001, it would change the domain ID wouldn't be 2 anymore, and then the routes I see on the other end would be E2 routes and not a OIA route, right? So when it comes out of the when it comes out of the PE on 15, if you show IP route OSPF, instead of showing enter area, this will say E2 because the domain ID is different. Same thing with EIGRP. If I use the autonomous system of 100 on one end, and then the other one is 101, then it's just going to show me as a DEX route and not a D route. So it's going to look like an internal route with administrative distance of 170 instead of 90. So we looking here. Now I'm gonna give you a little extra game here, extra sauce here when it comes to like routing and how to look at the routes. But you see how the administrative distance here is 90, and this is the feasible distance here. And then if I did a different autonomous system number, this would be 170 because it would say DEX. And if we show the EIG topology, here we go. So we got the feasible distance, reported distance. So like I said, this is the feasible distance. This is the reported distance, stuff like that. And if you know anything about feasible successor, the route reported distance has to be shorter than the feasible distance. Then you can use it as a feasible successor, and then you can use your variance command and then do unequal cost multipathing, or ECMP if you want to call it that. Another side quest extra game, and then everything is on P. That's what you want to do. You want everything to be P, because if it's active, you got a problem, and that's where you got your stuck in active thing going on. And then you have to worry about that whole nonsense. But if you use stubs or summary, you can get around that. But yeah, you don't want any of your routes in your EIGRP to be active. You want to be passive, so you want to be P. You'll be good, right? And then if you look at the EIGRP neighbors, we're good here. Our queue count is 0. You want your queue count to be 0 because if it's not, that means you got something going on with the messaging and it's not establishing the neighborship, right? You got your RTO, you got your sequence number. So you got everything's good, right? From the EIGRP perspective. I just gave you a little bit extra stuff about EIGRP. And this is why I said, even though this is CCIE kind of like service provider stuff, all the stuff that I just rambled off to you is really like CCIE, EI stuff, enterprise infrastructure stuff, or CCNP stuff, all that stuff I just rattled off. So it's good to have that, and then you can jump into other things. Now I'll probably create a video. I'm going to ruffle some feathers because I believe, and I always say that the CCIE enterprise infrastructure is a hard test, but it's your beginner CCIE. It's a beginner CCIE, and it's a very super hard test. But you'll realize when you go into the other tracks that you really don't know a lot about the other stuff, how routing and all that works. And even if you get multiple CCIEs, this is a terrible side quest, by the way. Even if you get multiple CCIEs, it's still like you're always learning. So the CCIE, if you're going for it for your enterprise, get it, but just realize there is more. The rabbit hole is a lot deeper than just that level. It's super hard to get that thing, to get your first number. But when you start going into other tracks, you will realize, wow, I thought I knew MPLS. I always use this as an example. I thought I knew MPLS, and then you get over the service provider and you're like, I didn't know a thing about MPLS. I thought I did, but I didn't. So I may create a video about that, ruffle some feathers. But back to this off the side quest. So what I'm going to do, I'm going to do the BGP part, so 16 to 13. And we're just going to just validate that we have connectivity. And then we're going to do a trace route from um, 16 to 13, and we're just going to watch the trace as we go here. So you're going to see that segmented LSP stuff and all that. So let's ping. It was 13 from the source of our loopback. So we validated that that was working. And then we're going to do trace route. And then we're going to just watch the trace route. So what you're going to do is you're going to see it hit 7, go to 6, go to 5, go to 4, go to 2, and go to 1. But when it goes to 5, you're going to see that segmented LSP. So you will not see a transport label. You'll just see the VPN label. The VPN label will get swapped with a different VPN label that will get a transport label put on top of it, and then it'll go to 2. Just like option B, but instead of doing the VPN v4 at the ASPR, you're doing the VPN v4 neighborship at the route reflector. So we're at 5 now. So one should, there we go. Oh, actually, no, not the segmented. Yeah, B is the segmented LSP. I don't know why I said that because we have a full flow now. We don't technically have a segmented LSP in this one. It will keep the transport label like it's a full LSP all the way through. So remember in option B, totally did a brain fart on that. Remember on in option B between ASBR 4 and 5, it went to like a V, it had one label, then it swapped to one label and went all the way through. Well, because we're technically doing a full LSP all the way through, as you can see, the transport label and the VPN label goes all the way through now. The one thing I want you to pay attention to is the service level, a label or VPN level label never changes. So it's the VPN label is 107. So as it's moving through 1 or 2, sorry, moving through network 65002, this is router 6, this is router 5, here is the transport label for 4. So this is just sending label, right? Then it goes to 2, which still has the 107. Then 107 is the last label that's popped off, and then it turns into a regular IP packet. So this is where the PHP process happens right here, because that got popped. The last label got popped off. Our last transport label got popped off, and it just left the VPN service label here. So I got a little mix up there between with option B and C. See, even I can forget some things. Everybody's human. But as you can see, it's a full label switch path all the way to the other end. All right. And that's the difference. If you, well, again, watch the video on option B so you can actually see the segmented LSP where it's just one label between 4 and 5 and no transport label on top of that. And that is MPLS Inter AS L3VPN option C. Watch all videos. Watch all the videos up to this point. Watch option A, option B, and this one. Watch it 2, 3, 4, 5 times until you get the concept. Because the next one I'm going to be doing is option D. We'll have well, we're gonna have the setup of option A from a lab perspective. It's gonna look like option A, but it's going to have a mixture or a combination of option A from a data plane standpoint, but option B from a control plane standpoint. And it marries the two. A lot of more configuration. Um, a lot of people don't talk about this option, and I haven't seen option D in the wild as much as option B. Like option B is the one I see the most. Option A, if it's a small service provider network. Option C, rarely going to see that because, again, nobody wants to share their internal network with another service provider. And option D, not as much because most people don't know about option D. So this is Don for Padlock Technologies again. I hope this video was informative. Um, if you like this video, please comment. Don't forget to share, comment, like, and subscribe. Other than that, be on the lookout for the option D video. Thank you and have a nice day.